Sit still. Pay attention. Stop fidgeting. If you heard those words enough times as a kid, your brain learned something. Not how to focus. Something else. It learned that the way it naturally worked was a problem to be fixed. Here's what nobody told you. For 200,000 years, that brain didn't just survive, it led. Then we built a room, put a chair in it, and called every brain that couldn't stay in it broken. Before we get to the room, we need to understand the brain that walked into it. For almost all of human existence, your ancestors had no schedule, no desk, no textbook. They had a landscape, constantly shifting, full of things that wanted to eat them, and they had to read it fast, every single day. In that world, the brain that never stopped scanning wasn't distracted. It was doing exactly what it was supposed to do. The one who got bored of a picked over berry patch and moved on before anyone else. That wasn't impulsive. That was the fastest thinker in the group. The one who noticed everything all at once. The snapped twig, the change in the wind, the shadow that moved wrong. That was the early warning system the whole group depended on. Not personality quirks, not problems. The difference between the group eating tonight or not. Now, here's the first thing most people get wrong about ADHD. They call it an attention deficit, a shortage, like the brain ran out of something. But that's not what's actually happening. The ADHD brain doesn't produce less attention. It produces attention in every direction at once, scanning everything, rating everything, unable to switch off. It's not a deficit, it's a surplus aimed at the whole world simultaneously. The problem isn't that there's too little focus. It's that the brain was built for an environment where focusing on only one thing at a time could get you killed. The word deficit was chosen by people who needed children to sit still. It described what was missing from the classroom. It said nothing about what the brain actually was. So in 2024, a team of researchers decided to find out. They built a foraging task. Find resources, move on when a patch runs dry, collect as much as you can. The same basic challenge your ancestors faced every single day. Then they ran two groups through it, people with ADHD traits and people without. The people with ADHD won. It wasn't close. They moved faster between patches. They collected more overall. Every trait that gets marked as a problem in a classroom, the restlessness, the impulsivity, the inability to stay in one place, turned out to be exactly the right equipment for a world where hesitation costs you everything. But the foraging study only tells you what these brains can do. It doesn't tell you where they came from. For that, you need to understand a single gene. It's called DRD/7R. Think of it as the brain's novelty dial. It controls how strongly you're pulled toward new experiences, new risks, new territory. Researchers call it the hunter's gene. It drives impulsivity, reward seeking, and the constant itch toward whatever is new and unexplored. It also shows up at significantly higher rates in people diagnosed with ADHD. And here's what makes it strange. This gene isn't rare. It isn't some fringe mutation that slipped through. It appears at high frequency in nomadic populations all over the world, people who move, hunt, and never stay in one place for long. The more nomadic a population historically, the more common this gene. The more settled, the rarer it becomes, which means this gene didn't survive by accident. It followed the hunters, all the way from the ancient world into the present. So researchers went looking for living proof. In 2008, an anthropologist named Dan Eisenberg traveled to northern Kenya to study a tribe called the Arial. Some of them still lived as nomads, moving constantly, hunting and herding across open land. Others from the same tribe had recently settled into villages and started farming. Both groups carried the DRD/7R hunter's gene. Eisenberg measured one simple thing: who was eating well, who wasn't. In the nomadic group, the men who carried the hunter's gene were better nourished than those without it. Stronger, healthier. The gene was doing exactly what it was built to do. In the settled group, same gene, same tribe, same generation, those men were worse nourished than those without it. Not slightly worse. The advantage had completely flipped. Same gene, same people, same century, two different environments, two completely opposite outcomes. The gene didn't change. The room did. Now. There's an obvious question. If this brain is so well built, why does it cause so much real pain? The failed grades, the lost jobs, the feeling of being permanently behind everyone else who seems to find it so easy. Here's what the diagnosis leaves out. The ADHD brain doesn't only scatter, it also does something called hyperfocus. That's when the brain locks onto something genuinely engaging, a problem it finds interesting, a challenge that feels real, and it simply doesn't let go. Hours disappear. the outside world goes silent. It's the same system that once tracked prey across open ground for an entire day without breaking concentration. The hunter's brain finally running at full power. The condition is called attention deficit hyperactivity disorder. The word deficit is right there in the name. The hyperfocus, the part where the brain produces more sustained, intense attention than most people can voluntarily generate, didn't make it in. Someone named this condition after the half that looked broken in a classroom. The other half, the part that would have made someone an extraordinary hunter, apparently didn't seem relevant at the time. So the same brain that shuts down in a 2-hour meeting can lock in for 6 straight hours on something that actually engages it. Not because it suddenly found discipline, because it found prey. The system works. The environment just rarely gives it anything worth hunting. Here's where it gets genuinely uncomfortable. In Sweden, researchers tracked which children were being diagnosed with ADHD. They found something that should have changed the entire conversation. Children born in December, the youngest kids in their school year, were 30% more likely to be diagnosed with ADHD than children born in January. Not because their brains were different, because the Swedish school year starts in January. A December child is being evaluated against classmates who are nearly a full year older. Their attention span, their ability to sit still, their impulse control, all being measured against kids with 12 more months of brain development. The diagnosis wasn't only finding a neurological pattern. In many cases, it was finding a child who simply hadn't had enough birthdays yet. We looked at that child. We opened a file, and we wrote disorder at the top. ADHD only became an official diagnosis in 1968, when it was added to psychiatry's rulebook, the Diagnostic and Statistical Manual. Think of that book as the official list of recognized mental conditions. Before 1968, the traits existed. The restlessness, the scanning, the inability to stay in one patch. The children existed. But the verdict didn't. The label only appeared once we had built enough classrooms, enough offices, enough systems that required stillness to function. That the mismatch became impossible to ignore. The diagnosis didn't discover a condition. It named a collision. And the collision was always one-sided. The room didn't move. The child got the file. Nobody voted on which brain civilization would be built around. Farming demanded a very specific kind of focus. Stay in one place, repeat the same task, wait months for a reward, tune out everything else. That brain slowly became the template. Then we built schools around it, offices around it, report cards around it, and every brain that couldn't perform inside those walls slowly became a diagnosis. Environments, unlike brains, can sometimes be changed. Not always, not easily, but the first step is knowing what you're actually working with. Not a deficit, not a broken attention system, a brain built for a world that moved fast, rewarded the bold, and punished anyone who stayed in a depleted patch too long. A brain that, in the right environment, doesn't just cope, it leads. Find the context where the focus arrives without being forced. Not the task you drag yourself through, the one where hours vanish before you notice. That's not a lucky accident. That's 200,000 years of selection pointing at exactly what this brain was shaped for. Sit still. Pay attention. Stop fidgeting. Somewhere on open ground, 50,000 years ago, a child heard none of that. They were already moving, already scanning, already at the next ridge before the group decided to leave. Someone opened a file on that child once. It didn't say disorder. It said, first one to see it coming. Now that you know, your brain might be one of the oldest survival tools in human history. You might also want to know why ancient humans almost never felt lonely. That video is next.